So this is number 72. And the title is Inscribed Angles. And an inscribed angle is an angle that has its vertex on the outer edge of the circle. An angle that has its vertex on the outer edge of a circle. So let me show you what that looks like. Here's a circle. And the angle, well, we've been talking about central angles, whose angles are at the center of the circle, but this is different. This angle, the vertex, is on the outer edge of the circle. So that's called an inscribed angle. So don't draw this picture because we've already had this information, but when you have a central angle, this is a central angle, this one's inscribed, this one's central, different kind of angle. If this is 80 degrees, then what's this? How many degrees? If this is 80, what's this? Also 80, right? So we've been talking about the fact that a central angle has the same measure as the arc. That's with central angles. But inscribed angles are different. The measure of an inscribed angle is half the measure of the intercepted arc. The measure of an inscribed angle is half the measure of the intercepted arc. So if this arc is 80, then how big is this angle? Half, right? So 40 degrees. Because the angle, the inscribed angle is half the intercepted arc. So over here, when it's a central angle, the angle and the arc match up. They're both the same. In this case, both 80. But for an inscribed angle, they're not the same. If that's 80, that's 40. So it's half as much. Okay, then a couple of other theorems. If two inscribed angles intercept the same arc, two inscribed angles intercept the same arc, now I know you're really anxious to hear what happens in this situation, but I'm going to make you wait. I know it's very exciting for you. but I want us to see what this situation looks like before I tell you what happened. So we've got two angles intercepting the same arc. So draw a circle. And then draw an inscribed angle. And then that inscribed angle is hitting this arc. So that's called the intercepted arc. So we have one inscribed angle that's hitting that arc. But the situation here is we need two inscribed angles hitting the same arc. So we need to draw another angle that intercepts that arc. So I'm going to come off to this direction. So there's the second angle that hits that arc. So there's a lot of lines going every which way now, so it's kind of hard to see what's going on. There's one angle that's hitting that arc, and then here's another angle that's hitting that arc. So we have two inscribed angles intercepting the same arc. Okay, now I know you've waited long enough, so let me tell you what happens in the situation. Then the angles are congruent. So if this angle was 50, what would this angle be? 50 as well, because they are intercepting the same arc, so they're congruent to each other. So if that's 50 degrees, then that's also 50 degrees. If this is 50 degrees, how big is that arc? Good, 100, because it's twice as big, right? If that's 100, that's 50. So if this is 50, that's 100. So these will both be 50, and then the arc will be 100. Or whatever the numbers are. Okay, one more theorem. This one says, if an inscribed angle intercepts a semicircle, if an inscribed angle intercepts a semicircle. What's a semicircle again? Yeah.
Isn't it just like a circle cut in half?
Half of the circle. Good. So here, there's the semicircle. Looks like a bearded man now. Okay, so we need an inscribed angle intercepting that semicircle. Now it looks like you have the half. So here's the inscribed angle intercepting the semicircle. So how many degrees is the semicircle? 180, right? Because it's 360 all the way around, right? So 180 half the way around. So this is 180 degrees. So then how many degrees is that? No, they're not the same. If it's a central angle.
Oh, so 90 degrees?
Yeah, because it's half. Yeah, so this would be 90. Good. So if an inscribed angle intercepts a semicircle, then it's a right angle. The reason why that works out is because the semicircle is 180 degrees, and the inscribed angle is half as much. Everybody okay? All right, the hole punches are in the back of the room, so just start them there and send them up. And the title is Inscribed Angles. And we're going to start with number 6A. Here's the picture on 6A. So the directions say solve for x. The whole bunch is coming up. So what equation could I write? Yeah, Taylor? 2x plus 4 equals what? You have the right idea, but you're going the wrong way. Yeah, Judah? 2x plus 4 equals 64. So it's this that is half of that, and you just got it mixed up and thought that this was half of that. So if this is 32, then that's going to be 64, twice as big. So 2x plus 4 equals 64. And then you just subtract the 4 to the other side, and then divide by 2. This angle is marked as 6x plus 8. And that's how many degrees it is. So what can we do for this one? How many degrees is this? 180, right? Because it's half the circle. And then this angle is inscribed. So how big is this angle? 90, right? Because it's half the 180. Inscribed angles are always half the arc. Excuse me. Everybody see why that's 90? Okay, so 6x plus 8 equals 90. That's this one here. If an inscribed angle intercepts a semicircle, then it's a right angle. So we have this semicircle getting hit by the inscribed angle, so that's why it's 90. So then you just subtract 8 and divide by 6. That's 13.6 repeating. This angle is marked as 3x plus 12. This angle is marked as 6x minus 24. So we got to solve for x. Yes, ma'am. Yes, good. They're equal. How do we know they're equal? Yeah. They intercept the same arc. Good. See how this angle is hitting this arc? And then see how this angle is also hitting that same arc? So if two inscribed angles intercept the same arc, then they're congruent. So that's why 3x plus 12 equals 6x minus 22. And then you just subtract the 3x over. Add the 24. And then divide by 3. Everybody doing okay?